All right, so I think I'm recording here. Let's take a look at solving these two equations. They're both radical equations. Um, we are going to, in each case, get the radical by itself and then square each side and check for extraneous solutions. So on the left one, on number 6, the radical's already by itself. And in number 7, we're going to have to do some algebra to get that radical by itself. So let's start here with number 6. Let's square each side of this equation. So on the left, we're squaring the binomial x plus 2, and on the right, we're squaring that radical. Now, exponents don't distribute. This is not x squared plus 2 squared, and many students are going to write that. It's x plus 2 times the quantity x plus 2, which is going to give you x squared plus 4x plus 4. See, you're going to have a middle term. On the right-hand side, the radical goes away, and we have 2x plus 3. So we have a quadratic equation. We want to get this quadratic equation in standard form, and then we can try to determine, can we factor it? And if we cannot factor it, we can use the quadratic formula or completing the square to get our solutions. So let's take away 2x from each side. So I have x squared plus 2x. Let's also subtract 3 from each side. And so 4 minus 3 is 1, and that equals 0. So on the left, this factors to x plus 1 quantity squared, or x plus 1 times x plus 1. This gives us a possible solution of negative 1. So let's plug that in to the original equation and see if whether or not this is extraneous or not. Is this really a solution to the original equation? We know it's a solution to this quadratic equation, but when we squared each side, that was an invertible operation, a non-invertible operation, and that may have introduced extraneous solutions to our original equation. So on the left-hand side, I have negative 1 plus 2. And the question is what will we have on the right-hand side? We've got 2 times negative 1 plus 3. So on the left-hand side, negative 1 plus 2 is 1. And on the right-hand side, negative 2 plus 3 is also 1. And the principal square root of 1 is 1. So this does check, and x equals negative 1 is in our solution set. All right, so let's take a look at number 7. Let's subtract 2 from each side. So we've got 3 times this radical is equal to x minus 2. Now, I'm going to go ahead and square each side now. You know, I've been saying isolate the radical, and that's true, but maybe I should have been saying isolate the term that contains the radical, because if I divide both sides by 3, I'm going to introduce fractions on the right-hand side. And when I go to square that, that's going to make it a little more difficult. So if I come in and square both sides of this equation, I just have to remember to square that 3. You know, and many students will forget to square that 3. See, you have this 3 has an exponent of 1 and a power raised to a power. You multiply those exponents. So 3 squared is 9. And when I square this radical, well, I get x minus 2. On the right-hand side, I've said it many times, exponents don't distribute. So I get x squared minus 4x plus 4. So this is a quadratic equation. I want to get this in standard form. Let's go ahead first and distribute this 9 through 9x minus 18. And let's get all the terms on the right-hand side so that we have 0 on the left-hand side. So if we take away 9x from each side, we've got our 1x squared minus the minus 4x minus 9x is a minus 13x. If we add 18 to each side, we'll have 22. This factors to x minus 2 times x minus 11, because negative 2 times a negative 11 is positive 22, but those factors add up to negative 2 plus a negative 11 adds up to negative 13. This gives us potential solutions of positive 2 and positive 11, but they could be extraneous. We're not ready yet to say that that's our final answer. All right, so let's check the x equals 2. If we plug in 2 on the left-hand side, we have 3 times the square root of 2 minus 2 plus 2, and the question is that going to equal 2? Well, 2 minus 2 is 0, square root of 0 is 0, and 3 times 0 is 0, and 0 plus 2 is 2. So yes, 2 equals 2, and this checks. What about 11? Will it check? All right, so on the left-hand side, we have 3 times the square root of x minus 2, but we're replacing x with 11, so we've got 11 minus 2. Don't forget the plus 2 on the outside of the radical, and then will that equal x? And we're saying, big question mark, will that equal 11? So 11 minus 2 is 9. Principal square root of 9 is 3, and 3 times 3 is 9, and 9 plus 2 is 11, so they both check. So both of these are in the solution set, and the only members of the solution set for our problem in number 7. So that's our final answer. If you have any questions, don't be afraid to ask. Let me know if I've made any silly type of errors because I can edit these videos. I hope this helps, and I will talk to you later. Bye.